Now we'll Be'ezer Hashem Yisbarach discuss the inyan of Shinui Mara. So the Rambam is showing it. This is like a new. Up to now we discussed the idea of we got to know the Oirich Rishon means the difference of the longitude of the sun and the moon. That's called Oirich Rishon. And we also discussed in the previous Shiurim that there is something that is called Netiyas Hamilke. That's the inclination of the ecliptic towards the horizon. And that keeps on changing. It can go up, fluctuate from 83 to 38. And there's a formula to tell you at each given moment, if you know what part of the celestial equator is on the horizon, you can also know the information what is the Netiyas Hamilke. Also, we want to know how much degrees of the ecliptic has set. We said that these two formulas, they both are. I'm going to show you this picture here once more to see how these are related. Okay, take a look at this ACB. So, CB is the local horizon in Eretz Yisrael. AC is the part of the ecliptic that has set. And AB is the celestial equator. And since we know the angle of the celestial equator towards the horizon, that is 58. So that's B. The big B is 58. We also know that we are given the celestial equator that has, let's say we know 30 degrees has set. We can figure out, also we know this angle here is 23.5 degrees. That's the angle of the ecliptic towards the equator. We know three angles. We can know also this angle AC. That is the angle of, and we explained that that is the why the Rambam says that there's two limits. He starts off the Rambam in Perek Yud Zayin Halacha Gimel. He explains that it depends which part the Yereach is. He explained that very, very nicely in previous Shiurim. That depends. Certain parts of the ecliptic take longer to set. There's a bigger chance to see the moon, even though it's small. And also we explained that there is this angle here that really we're more interested in the angle here that you extend this line. So we have an angle here that's called an Netiyas Hamilke. That's what the inclination of the ecliptic towards the horizon. That is 180 minus this. Okay. Now we can Be'ezer Hashem Yisbarach Okay, let me go back to what we're doing now. Okay, this one. Now we can start. The Rambam explains Shinui Mara. What is Shinui Mara all about? So, take a look at this diagram. This circle is a Kader Haaretz. And obviously, it's not a full sphere. It's just like one slice. And there's a person standing here. Any place. Obviously, he can stand. It's not the North Pole. It's wherever he stands. We put that on top of the picture. You can be in New York, in Los Angeles, in Eretz Yisrael. We just make a diagram imagining a person is standing, and we make it that a person should be on top of the world. Why not? So it's easier to understand the picture that way. So we take a guy, we put him on a certain point on the earth. And this line here is called the horizon. It means he can see the blue line of the page. You can see. So here there's an object called S. S is not the sun. S is any heavenly object. It could be an airplane, a balloon. Now let's say that the object S is right here on the paper. So you can ask this guy, where is this object? He'll say, this object is right now on the horizon. And let's say there is, you see there is a, here there's a, let's assume that there's a star here. Far away, there are stars. As we always say, that there's millions of miles away, there are stars. So the background, very far away in this direction, stars, all over the place. Imagine there's a huge circle, another circle around this millions of miles away that has stars on it. So you ask this guy, what's the background of this point S? He'll tell you a certain star. Might be a certain star in the ecliptic. Now, you ask this guy, now this is not imaginary guy, a guy that's standing in the center of Earth. This is purely imaginary. Imagine you drill a hole and somebody's in the center of the Earth and he has a big cave and he can look straight from this. He has a cave that he can look all the way till his eye reaches this balloon here. We'll ask him, where is this balloon? His eyesight sees it, up, continues. So he sees a different star in the background. So we see that when you want to describe this object, what's the background, depends whom you're asking. You're asking a guy that's standing here in New York, Los Angeles, or you're asking a guy that is in the center of the Earth, imaginary person. So, here's an interesting fact. When we say all the things that we said till now, for example, we said the moon, we made a bonus, where the moon is. Let's even say the Emtsa Yereach. It is all about an imaginary person standing here. In other words, the Kadmonim figured out how they did it. I'm not going to go into, and I don't understand it. But they had a concept from figuring out different ways that it can be this, can be that. So they figured out an imaginary person standing here. If he would take his eyesight and continue, that's where he would see the moon. That's what we're discussing. All these cheshbonos are based upon this fictitious observer here in the center of the Earth. However, very nice. This is just good for theory. But in practice, when a person is standing in Los Angeles and the moon is on his horizon, let's say the moon is, now let's make this S into a moon. Till now we said it's anything. It can be a balloon, it can be an airplane. Let's say it's a moon. So we have here a moon by the point S. So we look in the math books. As we said now, the Rambam has a cheshbon. He tells you where would you find S? Means where would this guy here find S? He would find them on 31 miles. The oirech would be 31. It means 31 degrees, and the roicha would be 5. Yeah, we said that's his address. We find the oirech hayereach and the roicha. The oirech amiti. After doing all kinds of stuff, we found out his true longitude and his true latitude. Oirech and roicha. But, we have to make a big but, that's for somebody who's standing here. So this guy sees the moon, and if he continues his sight, he would see him at 31 oirech and 4 roichav. That's how the calculations were done. But we need to adjust it now for the person that's standing on the surface of the Earth. And he's seeing the moon against the star here. So it's lower. It's this angle here. The change. We need to change the angle. You see this angle? This angle here. This angle is the difference of the Shinui Mara. Since the moon appears now by him on the horizon, for this guy it appears here. So this angle is the change of the moon that's visible in contrast to the moon that's calculated. Now, this angle is it's not a simple angle because it's an angle, but this angle, how did we do? We know if the, now let's you know what, let me say something. We know that the ecliptic, if it would be directly, it would be, imagine a circle that's perpendicular to the horizon of the person. So you make another circle here. Then it would be exactly a shinui just in the oirech, in the longitude of the ecliptic, and 0 on the roicha. But since the ecliptic is not exactly perpendicular to the horizon, now perpendicular, I hope you understand. Imagine you're in an empty place, in an empty baseball court, and you draw a line that's perpendicular. Means it's not to you. It's not inclined towards your horizon. It's a straight. It goes up above your head and down. That's called perpendicular. Then, if that's the case, then this angle, and imagine that it's the ecliptic, that perpendicular great half circle. So then it would mean, very, very simple, that the calculated, let's assume this angle here is 10 degrees. So let's say the calculated place of the moon is 50 degrees. So we go, it's 45 degrees. It means it's a shinui oirech of 5 degrees. Because that's how much the angle is. And it's a straight, it's very simple, straightforward. However, since the ecliptic is inclined towards the horizon, so when we go down, so to speak, this angle here, we are actually traveling in two directions. We're traveling in a little bit, we're declining, we're subtracting the address of the moon in the longitude, and the oirech, and in the roichav. Now, if it's hard for you to understand, it's a 3D thing, so it's hard to grasp. I made a 2D picture. It's much easier to understand this way, and it's almost 100% accurate, this picture, because when we're dealing with small triangles, so we can assume that the properties of a regular triangle, we don't need to use spherical trigonometry. So first ignore this, don't look at this picture, just look at the left side of the page. Now imagine this is oifik marabi, means this whole paper here is the western, you're facing this, imagine you're looking at the paper, that you're standing outside on the street, and you're looking towards the west. The western area. This is like, this area here is like the wall. It's like close to the horizon. This line is the horizon. And again, we're not making anything circular here because it's such a small section that for all practical purposes, it can be like you have a paper. You have a paper, and that represents the horizon. Now, when you stand facing west, then you know that on your left side is Durham, your right side is south. So this is north-south. Now, take a look at this. This is the Galgal Mazoros. Imagine it's, right now, Tle is on the horizon. So we know from previous videos that when Tle is on the horizon, it's very steep angle. It's 83 degrees angle. We'll have to stop here because this is a long video. So we'll have to continue soon to explain this picture.